This is Higher Maths. It's question from the 2002 paper 1, so a non-calculated paper, and it's question 11. Okay, so this looks like a kind of log question. If you have not completed this one before, freeze the video and try the question. I'll show you the solution. Okay, the graph illustrates the law y is equal to kx to the power of n. If the straight line passes through A, which is 0.50, and B, which is 0, 1, find the values of k and n. Okay, so let's go ahead and start this one off. What we'll do is I'll start off with the equation, or the relationship that we've got for the graph, so that's us starting there. What I'm going to do with this is I'm going to unravel that and I'm going to put it into the form of y is equal to mx plus c. So I'll take the logs of both sides, and the log that I'll take will be the log base 5, okay? So here we go. What we'll do now is I'll just use the law of logs, and where we're multiplying we can separate them by adding two logs together. So I'll go for this one. So it'll be log base 5k plus, and it will be log base 5x to the power of n. I'll then use the power, I'll bring that power of n down to the front of this one here. Okay, and then I'll just rearrange that in terms of y is equal to mx plus c, just the straight line equation. So what I've got here is I've got log y to the base 5. I'm going to change this round and pull it over to here, so I've got n here, and that's going to be a log base 5, and it's going to be of x, and what we've got here is 5k. Okay, so this now is in the form of y is equal to mx plus c. Okay, and I know that n is just going to be equal to my gradient, so I could work out the gradient and just take it straight from there. The way I'm going to do it is I'm going to show you it with simultaneous equations. Reason for that would be if we don't have any of the nice values that would be cutting through the y-axis, then certainly we may have a bit more difficulty. So let's just do it by simultaneous equations and by substituting these 2 points in. So the first point I'm going to put in will be the point A. So what I've got is, they're both log base 5s, the axes, so I'm just going to take the numbers straight from the graph. So first equation that I've got is 0, n, and that will be 0.5 plus log k to the base 5. Okay, so there's my coordinates there, 0.5 and 0, 0. So that's the first coordinate substituted in, so that'll be my first simultaneous equation. Right, let's go for the next one, and I'll use this point here, the 0, 1. So 1 is equal to n 0 plus log base 5. So there is an easier way to do it, you know, if we've got some easy points, but I'm just going to show you this method here. Let's go for equation 1 take away equation 2, and what I've got there is 0 take away 1 will give me minus 1. It's going to be equal to 0.5 n, and what we've done there is we've got rid of these through simultaneous equations. So from there what I can see is minus 1 over 0.5 is equal to n, so n is going to be equal to minus 2. I could have converted that to half, and that might have been easier to see how we would work that through without a calculator. Right, so once I've got this part here, what I can do is I can go forward and substitute the minus 2 into one of the equations here. What I'll do is I'll substitute it into equation 2, because that looks like the easiest route to go. So what we'll do is from there, we'll substitute n equal to minus 2 into equation number 2. So what I've got is 1 is equal to minus 2 times 0 plus log k to the base 5, okay? So this is going to work out to be 0, so I've got 1 is equal to log k to the 5, and what I'll do is I'll just convert this into exponential form. So change to exponential form. Right, from there I've got k is going to be equal to the base, which is 5 to the power of the 1, okay? So from there I can see that k is going to be equal to 5. So if I was to replace that back into the original equation, so what I've got is, the original was y is equal to k x to the power of n, so my equation now would be k is 5, x to the power of minus 2, and that would be that question there complete. So marking for this one here, we get 1 mark for taking the logs of both sides. I'll get 1 mark for getting the equation into the form of a straight line, so I'm going to take a mark for this one here. I'm going to get a mark for getting the n value, a mark for getting k is equal to 5. Okay, so 4 marks for this question here. So this type of question just always relies on unravelling the y is equal to k x to the power of n. If you can go straight from there to there, that's fine, but if you unravel it quite simply, you'll be able to make sure you don't make a mistake with that. Okay, as I said, simultaneous equations or alternative ways to do that would be work out your gradient, and you know where your y-intercept is, and that's why you get log k base 5 is equal to 1, and working things through from there. Okay, 4 marks for that question.